Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I welcome you all to the next session of the Linux lecture series. In the last session, we talked about the div directory, device directory, which contain entries for all the characters and block devices that your Linux system knows about. Today, we are going to talk about the terminal, which are also a type of character special devices. Before I talk about the terminal attributes, let me brush up your memory by drawing a diagram that shows the working of a terminal and a terminal driver. Okay, the overview of terminal devices. Overview of terminal devices. Well, let us suppose that this is our system having a process P1, and this process is communicating with a terminal. Let me draw a terminal over here. And we all know that a terminal is a device having a keyboard and a mouse. Here is a user. Well, a terminal is a device that is used by a user to communicate with Unix processes. We can say that a terminal is a source of data. The process P1 shown over here considers this terminal as a source of data because it can receive characters from it. The characters a user presses on the keyboard are received by this process. Suppose this process is a bash shell program, so whatever the user types on the keyboard is sent to that process. Similarly, this process P1 considers this terminal as a destination of data. So when the user types a command and sends it to the bash process executes that command and writes that output to the attached visual display unit. So that means for a process, a terminal is a file that it can read and that it can write. Students, it must be kept in mind that like all other character devices, a terminal is also an unbuffered device. Let me change color. A terminal is an unbuffered device. However, the terminal driver program, let's consider this box as a terminal driver program. This terminal driver program do perform a bit of buffering while a user types characters on the keyboard. Once the user types characters on the keyboard, they are not sent to the process directly until the user presses enter. When the user presses enter, the entire line is sent to that process for processing. Okay, let's see that how can we read and write a terminal by moving on to a terminal. Okay, I am Arif. My present working directory is this, and my terminal is div pts sub 0. Over here, I'm also Arif. Let me be Kakamanna. Let me switch user. Okay, I'm over here Kakamanna, and the terminal over here is div pts sub 1. Let's suppose that Arif wants to communicate with Kakamanna via terminal says, what about a cup of tea? And instead of sending this string on to the same terminal, let's write it to another file whose name is div pts sub1. So when it presses enter, this string is written on this file, and this file is div pts sub1. Okay, so over here Kakamana wants to respond by saying, let's suppose, okay, let's go to salt and pepper. And instead of sending the output to the same terminal, it writes on to the terminal of Arif, and that is pts sub 0, and it says permission denied. So over here, let me do ls-l div pts sub 0. For Kakamana, this div pts sub 0 file is neither readable nor writable and nor executable, of course. This file can be read and written by Arif and can be written by the TTY group, and Kakamana is not member of TTY group, so that's why we have got the permission denied message over there. So if Arif wants that Kakamana should write on his terminal, so he should change permissions by writing chmod, giving write permissions to other on his file div pts sub 0. And now if Kakamana repeats the same command, you see the message has gone there. Similarly, if Arif wants, over here I am Arif and I just want to execute a command, let's suppose ls/home. If I execute this command, I get this output, and if I want the output of this command to go to Kakamana's terminal, I can use something like this, writing this command in backtick and sending the output to div pts sub 1. I think it is 1. Okay, so you have seen the output has gone over here. So gentlemen, what I just wanted to say, I just wanted to prove is that a terminal is a file and programs can read and write this file. I will like you to please explore certain commands like write message val that are used to write on someone else's terminal. Val is used to broadcast a message. If you are interested, you can always go through the command conspy as well as tty log. You can explore these commands and can find out that what the other user is typing on his terminal. So these two commands act like a key logger. They keep noting the commands typed by a user on the other terminal, and you can receive them via email, or you may receive them inside a log file. So let's move back and start talking about a bit more about the terminals. Okay gentlemen, let us extend this example by changing color, and let me say that this process can also communicate with another file that is residing on a disk. Regular files, let's suppose there is a regular file f1.txt. Regular files are kept on disk, we all know that, and the disk is a block device. Once a process opens a regular file residing on disk, there is a connection that is opened between the process and the file on disk, and it has certain attributes. And in some previous session we have seen that connection starting from the file descriptor to the system wide file table and to the inode table and then to the blocks on the disk. This open connection has different attributes, and one of the attributes is kernel buffering. Kernel buffering. That is bytes flowing from the process to the disk. Bytes flowing from the process to the disk are accumulated into the buffer in kernel memory and later sent or transferred onto the disk. And what we are going to do today is we are going to see, let me change color again, what attributes a terminal or a terminal driver can have. Remember, gentlemen, in the previous session we have talked about that the code written inside the kernel over here that helps this process to read and write data on the terminal is known as the device driver for that terminal. So we are going to explore the attributes. We are going to see that how can we examine the current attributes. The current attributes of our terminal. And finally, we're going to see that how can we change these attributes. Okay, so let us open another board and roughly talk about the major categories of these attributes. Attributes of a terminal. Sorry. Attributes of a terminal driver. The first attribute, the important attribute, is echoing. Students, you must have observed that whatever you type on your keyboard is echoed on the VDU, Visual Display Unit. This attribute of the terminal driver, if enabled, displays the character you type via keyboard on the screen. And it can be disabled, and you might have observed it while you type the passwords in Unix. You don't see those characters. Echoing was disabled at that time. The second important attribute was line editing. This attribute, if enabled, which is the default setting, allows the user to edit the command line by using backspace and maybe the arrow keys as well. And you all must have observed this as well. Another attribute is the carriage return and line feed. This is a trickier one. Well, let me try to explain it, the concept of input. Input is given from the user via keyboard to the process. Remember, students, the user types a command. For example, let's suppose ls, the user types ls/home on the bash shell prompt. The bash shell receives no data until the user presses the enter key. Until you press enter key, this command line is not sent to the bash process. And once the user presses the enter key and the process receives that line, something happens, and that is a carriage return character which has a ASCII of 13, I think, is converted into a new line character, and I think the new line is 10. So once a user press enter, instead of an enter, a carriage return at the end, the new line character is sent to the process. And similarly about the output, that is, once the process sends something to the VDU or to the user, once this command is executed, its output is sent to the user, and something tricky happens over there as well. The new line character is converted to the carriage return and new line character. So new line character is converted to a carriage return plus new line character. So we will observe this soon once we will go on to the terminal and try that. Let me move on to the fourth attribute. Fourth attribute is generally the line speed, which is the baud rate. Probably we will not be much interested in that. And finally is the size. And the size attributes of a TTY driver basically manages the number of lines and columns that are displayed on the VDU, and you can access the values of the size by the environment variables lines and columns. These two environment variables contains the current number of lines that are being displayed on your VDU and the number of columns. You can always use the tput command as well to view these attributes. Now gentlemen, let's move on to the terminal. Let's turn this. Let's move on to the terminal and see these things in action. Okay, I think I should close this and I should broaden up this and clear screen. Fine, there is a command that is stty. This is a command that is used to display the attributes. If you want to see the detailed attributes, you can use the -a option to it. Let's have a bird's eye view of, you see a lot of variables and attributes with corresponding values. We can divide these variables into three main categories. The first category is the variables with numeric values. You can see these variables which are having the numeric values. The speed, that is the baud rate, number of rows 21, columns 74. Other than these numeric values, there are certain variables which are having character values. For example, these are the variables which are having character values, like the quit character, the interrupt character, and so on. Similarly, there are certain variables which are having Boolean values. These are certain variables which are having Boolean values. So these all are variables. For example, echo is a variable, echo e is a variable, onLCR is a variable. If this Boolean variable is preceded with a hyphen sign, that means the value is off. If it is not, then that means it's on. So echo variable over here, it is having its value on, and if we change it with a hyphen, then that means it is off. Okay, before I start changing these variables, let me again come on to the board and talk a bit more theory about it. Okay, let me open another terminal, take white color. Let me divide these attributes into some main categories of the terminal driver attributes. Well, action performed by the terminal driver on the data passing through it can be grouped into four main categories. And the first category is input processing. By input processing, I mean once you type something on the keyboard and that data is passed to process P1, this data is going to the process. This is the input. So once you presses or passes some characters to the process, the processing carried out by the terminal driver on the character received is known as the input processing. There are a lot of things that happens, but we will like to discuss two important attributes. One is ICRNL, that means input carriage return to new line, which says that translate a carriage return to new line on input, as I have already said. The second is INLCR, which is normally by default off, which says input new line to carriage return. So this translates the new line to a carriage return character on input. The other processing type is the output processing. By output processing, I mean whenever this process wants to send something to the VDU over here, the characters which are passed by the process are processed by the terminal driver and then they are sent to the VDU. So what kind of processing is done? First is ONLCR. On output, O means output, new line to carriage return. The new line character is converted to carriage return plus new line character. The second one is OCRNL. By default it is off, which says on output translate the carriage return to new line character. Another interesting is OLCUC, and this is on output translate a lowercase character to an uppercase character. Well, gentlemen, keep a note of all these things. Soon we will go on to the terminal and we will practice them and then you will understand them properly. The third is the control processing. And under control processing, what actually happen is that means how the characters are represented within the terminal driver. And the variables, important variables are like C size, that represents the number of bits used to store a byte. Its value you will normally see its value as CS8. Then we can have the parod variable, parity. By default it is off, and if on, then parity used for input and output is odd, and otherwise it use even parity. Then we have C stop byte, C stop B. If on, then it uses 2 stop bits per character. By default it is off, that means it uses 1 stop bit per character. And the last one is local processing. And local processing bits basically defines what the driver do while the characters are inside the TTY driver. And some important are like iSig, which ignore the signals, ICANN on, about the canonical mode, echo, which echoes the character, and there are others as well. So then before you start get boring with this theory, let me put the board aside and start practicing all these things on the terminal so that you can understand these. Okay, let us see the total number of rows that our terminal displays right now. Stty-a. So you can see the total number of rows that the terminal displays are 21 and the total number of columns are 74. Let us change them. Stty rows, let's suppose 5. And now it will display 5 rows. Let's see that. Run the less program and tell it to view the PUCIT file, and you can see over here 1 2 3 4 5 total 5 lines are being displayed. So you can always change this. Let me set it back to 21, which was previous value, and let me do again at PUCIT, and you see now it behaves very normally. Okay, so let us talk about the arrays character. Let me clear Stty-a, the arrays character. The arrays character is this. Normally on everybody's keyboard, if you're using the US or British keyboard, the arrays character is the backspace or the delete key, which is represented by this. Let me write something on this terminal, and if I want to delete, I press the delete key. Every time I press the delete key, it deletes it. Basically, if I press Control Shift question mark or Control question mark, it is performing the same task. So the arrays key on my system is the backspace, which can always be accessed using Control question mark, and I can access Control question mark by Control Shift question mark. Okay, so control key, this key, arrays key is very important, because once we type something over here, let's suppose I want to say echo learning Linux is, and I have done a typo, I want to remove it, I can remove it, is fun, and I press enter, and then the correct command with the correct string goes to the process and it displays it. Let me change the arrays character. Let me change it to, let's suppose, character Z. Okay, or let me change it to character X. Stty-a. You see now the arrays character has been changed to X. Okay, let me write down echo learning Linux. I press space bar, I press delete, the delete character is repeated, and I press X, the character is deleted. So if I am pressing X, the character is deleted. Learning Linux is learning, oh, so it is too difficult to handle it. So let me Control C, and let me set it back to hat question mark, and now if I write, I have pressed backspace, it is working fine. So gentlemen, you can always change these values, and whenever you change these values, you must put them right afterwards, so that anyone else using this terminal should not have problem. And remember, whenever you have changed a lot of things and you don't remember the actual settings, you can simply write down Stty sane. By writing Stty sane, these all attributes are set to their default settings. Okay, let me do one more interesting thing, that is sleep 100, enter, Control C. We all have learned that we can press Control plus C to set signal number 2 SIGINT to the foreground process. And let me ignore all the signals. You can see that the interrupt character is Control C, which sends SIGINT, signal number 2. The quit character is Control backslash, which sends sig quit, signal number 3. And finally, I also have another character, that is suspend character, Control Z, which sends the sig TSTP, signal number 20. So if I want that the user should not be able to send any signal to the foreground process using the keyboard, I can say to the Stty command to please disable the signals ISIG. If you see over here, ISIG must be on, and I'm just, yes, ISIG is on over here, and I am making it off, and you can see now the ISIG interrupt signal is off. Now let me clear screen and let me sleep for, let's suppose 100, and let me press Control C, Control C, Control C, Control backslash, Control Z, Control Z. Nothing happens. Let me open another terminal. Let me say PS-A, and let me note the ID of sleep. Let me pass it a signal, let's suppose SIGINT 6280. You see sleep is running over here and it is not receiving any signal via keyboard, and I am sending it SIGINT and it says operation not permitted. Let me send, okay, it should have, let me see who I am right now. Who am I? I'm Arif, and over here it is terminated. It has said that operation is not terminated, but it has terminated. Anyway, we can always send some other signal using the kill command. It will of course be sent to this process for whom you have ignored the signal. So finally, let me again enable this Stty -a, and you can see it is enabled now. Okay, so let us have some more fun by making the echoing off. Okay, which is the normal case. Normally in whenever I type something, it is being echoed on the screen. As you can see, I am typing, the characters are being echoed and not sent to the program. Let me check out. The echo is on by default. Before doing this, let me show you the behavior of cat program. The cat is reading from the keyboard, and it is, once I press enter, the character goes to the cat program and it sends it to the video. See again. Learning Linux is fun. This character line is still with the TTY driver. I press enter, it goes to the cat program, and the cat program sends it back to the video. Okay, I press Control D, it is done. Let me do Stty -echo, and let me run the cat program. Now the cat program is running and I am writing something, and once I press enter, it will be echoed on the screen, and I'm writing something, and you see it is being echoed on the screen afterwards. And you see the problem? I have not been given the chance to correct the spellings of fun, and these 2 extra I's are at the end of this. If cat would have been running with echoing on, I would have corrected this line before sending it to the program. Control D. Let me do Stty echo, and now it's back. Stty -a. The echo is on now. don't forget to reset the variables back to their original values. Well, I hope you can of course explore rest of the attributes, but before closing, let me touch upon one more important attribute that is very important, and that is the modes of a terminal driver. Modes of a terminal driver. Well, there are three basic modes. One is known as the canonical mode, the other is known as non-canonical mode, and the last one, rarely used, is known as the raw mode. Let's talk about the canonical mode. If you can see that there is a variable I can on. Okay, over here. Input canonical. So that means canonical mode is on. The keys that I will press will be buffered inside the TTY driver, and I can edit the input, and after that, once I press enter, only then those keys will be passed to the CAD program. This is what happens. I have intentionally written wrong spellings. I have corrected them, put a full stop over here. Once I press enter, only then things will go there. So this is good. So canonical mode offers buffering facility, and with this buffering comes the editing facility. Well, gentlemen, there may be scenarios where you may want that the input should be made available to the foreground process character by character, without the need of pressing the enter key. This is what non-canonical mode is for. You might have worked with certain programs that work in this mode. For example, let me write down the mode program, which all of you must have used. So right now the mode program is running. Let me press Q. I have just pressed Q. It has just come out of the terminated the program. Let me run it again. I press Q and I don't press enter, and it respond to my input by terminating. Let me run it again, and this time I press the space bar. If you see, after pressing the space bar, I do not press enter. By just pressing space bar, it has moved one page down, and finally it has gone to the end of the file and terminated. Similarly, you might have worked on Vim as well. You might have observed that Vim worked in both modes. At times it works in the canonical mode, and at times it works in the non-canonical mode. So let me change to non-canonical mode, -I can on. You can see the canonical mode is off now. Right now I am in non-canonical mode. Let me run the CAD program and let me type something. Oops. I press a character, and that is sent to the CAD program, and the CAD program send it back to the std out. Let me press U. You see, I have pressed U once. The CAD program receives the U and send it back to the std out. So whenever I press a character, it is not buffered by the terminal driver, and I have no facility of editing. I am pressing the backspace. I have no facility of this. So gentlemen, non-canonical mode is really of interest. I would like you to go through two more variables. One is the min, whose value is 1, and the other is time, whose value is 0. These two variables work in close association with the non-canonical mode. Please go through the main page of Stty and see how you can perform a polling read. Let me write it down for you. A polling read, a blocking read, read with timeout, and finally a read with interbyte timeout. You can perform all these 4 kinds of reading with 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 min and time attributes and setting them with the non-canonical mode. Finally, one more thing, you might have seen that passwords are normally read uh, using echoing off. Let me write it for you. Enter password. Let me put a \c over here so that it receives it in the same line. And let me say read the password in the variable read password. So my password is arif.but. So this is very bad. You can see the password is being echoed. Everybody can see this password. So let me give a new command now. Let me say echo -e enter password \c for receiving it on the same line. Put a semicolon over here, and let me put a backslash to continue the command on the next line. And let me save the current setting of the terminal driver, old Stty, and the current setting can be received by the command stty-g and semicolon, and let me put a backslash. And now let me say that change the attributes of the terminal to no echoes, put a backslash. Let me say that now read a password. Over here, once you type the password, it will not be echoed because we have already gone to non-echo mode. Let me press enter. And after doing this, it will always be better if I can set back to my actual setting, which are being saved in the old stty variable. And finally, let me put a bit of makeup for putting a new line at the end. And let me press enter, I think. Okay, enter the password. I have entered the password. It is not visible to you. Now I'm going to press enter. And once I press enter, I am back on the terminal. And of course, the password which I have typed is there in this variable. Let me say echo $. It says arif.but. So that is all, gentlemen, what I wanted to say today. Once again, please remember this terminal is composed of a lot of attributes which can be divided into 3 categories. The variables having integer values, the variables having some character values, and the variables having some Boolean values. You can always change them and you can have fun and enjoy yourself. I hope today's session was informative. I wish you all the best. Allah Hafiz.